Hello everybody, welcome to Rocket Lasso Live. Episode 10. Is the audio working now? Testing. Is the mic back? All I did was unplug it and plug it back in again, so go figure. But when in doubt, unplug it, plug it back in. Okay, everybody, start getting those questions together. So, let's see. Some people have some questions popping up already on Twitch. Feel free to post on YouTube as well. I jumped in between both of them. The first question, Mr. Matt Dog has one saying something with a new dynamic system. I'll click on that, mute the tab, wait for this commercial to end, activate the correct screen, skip the ad, and pull this over here. All right, so you said about 50 seconds in. This is from Chace Paints, which presumably is some sort of actual painting process. And it looks like we're going to get some... Okay, this is kind of a... Okay, so they're dripping paint in kind of a pendulum type way. And yeah, this is going to end up making a very nice kind of repeating spiral pattern. It's going to slowly wind its way down. But I totally get the idea here. It's almost like a spirograph type effect. So yeah, it's probably going to end up making a nice looking pattern. I'm curious where it does end up. Yeah, and it's going to continue shrinking. You see how the circles are also getting smaller. That's kind of cool. I like the idea of it. Oh, look at that little drip in the middle. No. Okay, anyway. Cool. Thanks for the question. Let me... How do I remove this? Reports. And... Nope, not self-harm. It is spam. Sorry, we're getting some spam on the Switch. Okay, got rid of that. Okay, now, if we want to make this in a very literal way, we should be able to do it. I'm trying to think of... Like, we can use my usual technique, I think, that we've talked about in various ways, where the thought is we can drop things maybe dynamically or with a particle system. So if you're working with something flat, and yeah, let's do that. Let's work from something flat. So if we were to make a plane and a simple particle system emitter, and with said emitter, I'll move it up into the air, rotate it 90 degrees, and tell it to emit, I believe, 30. We're at 30 frames a second, so I'm going to say a birth rate of 30. So there should be, I think, one per frame, I think. And then we'll tell it to emit forever. And then if I tell the emitter to be really tiny, 0, 0, then now we have this emitter that's shooting out a, in theory, let's go to an angle we can see it, a constant stream. Looks a little bit inconsistent. We are at 30 frames per second. So is 30 not the magic number here? Because 1 is going to be like way too infrequent. Pew, pew, pew. 15 seems okay. I don't know, maybe it's just a visual inconsistency, but besides like doubling it, I don't know what I would want to do with it. But anyway, I'm going to, let's just do some random motion with a vibrate tag. Turn that on to regular position. And I don't know, let's go up to 200, 200, and go way slow, 0.1. So that's, you see how this is kind of moving around at a very consistent speed. I want to make, I'll make this a little darker so we can see it up against it. Okay, so yeah, you get this constant stream. So then we need to stop those particles from falling. So the simple way in this particular case would be a force. We don't use this very often. A deflector. And we'll aim that. It goes up or down, so we'll aim it like that. T for scale. And that's actually going to make the particles bounce off of it. But we can say, actually, don't bounce. So I think they'll just stop and stop dead. So you can see that we get this. They'll just start stacking up right there, which is pretty much exactly what I want. We need way more frames, so we'll let this continue traveling around. Now, they actually stop a little bit up into the air. And I guess maybe that makes sense because this old emitter is not going to be, based on their speed, depending on if they happen to hit a little bit higher or a little bit lower at that moment, it's going to, I guess, just pause it right there, which is actually not super great for our purposes. And we could probably make it a little bit more dynamic if we actually made these dynamic objects so they actually fall all the way down. So let's see if we can improve it a little bit with that. So I will make this show the objects, and we'll keep it as simple as possible with a cube. And it needs to be real tiny, 1 by 1 by 1. And we should be seeing, yeah, a bunch of tiny little cubes coming out, and they'll still be stopping there. But now I don't actually care about this deflector anymore, but what I would care about is a dynamic ground. So I'll say simulation, actually bullet, collider body, and then we'll make these cubes bullet rigid bodies. So they should be born with this speed, but then they're instantly dynamic objects. And they should be falling, and actually they're falling straight through the ground, which isn't surprising because they're going pretty quick. So for now, I'll set this to a speed of 0, which means they should probably take a little bit more time before they start accelerating down. But they're still going to pass right through this floor. Not super surprising, but I kind of need a cinema floor object. So I'm going to search for a floor and bring that in and make that the collider. And that should actually be hitting, I would think. So let's hit play on that. And now, yeah, you can see them actually piling up on the ground because they were escaping right. They're so tiny, they're escaping through the plane. So you can see all these piling up. And what I'd really like to do is stop them kind of dead. And it would be good if they weren't colliding with each other. I don't think we can stop them from colliding with each other. If I turn off self-collisions, are they able to pass through each other? Maybe if that was on the parent, maybe. And, you know, I want to make it a lot calmer overall. Potentially we can, I don't really care about follow rotation, and we could make this calculate based on a box, which in theory could make them stop quicker. Put a bunch of friction on both of these, so I'll give it like 200% friction, so they're very inclined to stop. Very jittery, but these are also very tiny, so I'll hit Alt-V, or Control-D rather. Go to Bullet Dynamics, and our overall scale should be smaller, so I'll set that down to like 10. We'll see if that makes those behave a little bit better. There's still a bit of a bounce, but I don't think I turned off bounce. So let's say no bounce, please. There's still some energy with the way that they're colliding. It's actually kind of interesting that it's so perfectly constant. No, we've got additional variables to think about right now. I'll pull this down. Yeah, that's interesting and consistent. It could just be that the previous one was existing as the new one moves in. This is interesting. It does look like they're able to pass through each other, which I guess in a way is good, but they're really, really jittery. We got a couple other things that we might set, though. I'm going to set the collision margin down to 0. The scale could potentially be smaller still. We could drain more energy, but man, I mean, we are working at a very tiny scale. I would think that those would be able to handle it, though. Let's give it some more energy drain, not too crazy. And let's start them over. Yeah, look at that really interesting, consistent collision. I wonder if... Okay, it is different if I put the tag on the parent or the child, which is interesting. And now, oh yeah, but the reason I put it on the parent was so that each of them was being seen as a kind of a whole, and now they're being seen as individual objects. So you can see how they're colliding and pushing each other out of the way. And they're still moving a lot, which not great. I mean, we can make them smaller. They're going to get so small it's going to be hard to see, but I don't think it's going to stop them from moving. And we put the collision margin down to 0. So I can't think of anything else that would like make these calm down a little bit. And look how they're just kind of spreading out and not staying static at all. I feel like I've gotten this to work better in the past. This is not cooperating that much. Now, I mean, there were some other things I was going to do. making that a little bit bigger so we can actually see it. A thought was we can limit these, I think, maybe, if I group that and make a simulation bullet connector, drop that inside along with it, and I would like this cube to be connected as a slider along its axis. And let's make sure everything here is properly zeroed out, just positionally. And the thought there is that these are going to fall now, and they're not allowed to move except for vertically. And you see we're actually getting these kind of very nice stacks going, which is not the specific technique I was going for, but it's working surprisingly well. And that is definitely forcing them to calm down. And it's, I hadn't ever thought of building something like this, but the way it's stacking these walls, even if it passes over the other one, it kind of stacks up on top of it as well. That was kind of fun. Now that's all the more reason that right now we're just using this random vibrate tag. That could presumably be significantly quicker. And, it would be better if we were even animating along a spline. But now you can see at least this is moving around. And what this is going to enable us to do, now that we've sort of got that working a bit, and what scale are we at? Here's a regular cube, so it can be moving further for sure. 444, 444. Okay, so now that we have a bunch of different dynamic cubes going, actually I'm not entirely sure that this will work because this isn't going to work because it's probably going to see the null. Anyway, well, let's just see what happens. I'm going to create a tracer. And if that tracer is supposed to be following the emitter, and I say, hey, connect all the objects. Oh, no. Okay, so what it's doing is what I thought, because the dynamics tag is not on the emitter, but it is on the cube. It is viewing each particle at its origin, but not where it drifted down to. So you can see we're getting this really nice traced line, but that line might as well just be tracing the original, like this could be a null just animated around and we'd be tracing that, and obviously that is not working anywhere near as nice as we would want it to. So yeah, interesting limitation there. I have a thought in my head that Ricochet could do something, but I don't really want to do it that way. Let me think. Let's see. For on YouTube, somebody's asking what we're making. We're attempting to make this cool, like, paint swirling thing where there's a cup on a pendulum swinging around. So we're just tackling the technical part of it right now before we worry about a particular motion. I mean, something to keep in mind, not that this is the most amazing, or there's so many different ways in anything in cinema to tackle things. And actually, what I kind of want to do is, let's make this, I want to make this kind of wall stacking thing a little bit more robust so we can kind of put that as a scene file. Boing! Just because I think that's kind of neat. And so I can save that for sharing. If you are supporting on Patreon, you get access to these scene files. I just kind of want this box stacking because I think that's kind of cool. And the steps per frame would go a long way to cleaning this up. It's kind of amazing how quickly those stack up on top of each other. But in any case, let me save that. And let's talk about a completely different technique. Scene files. Number 1. I'll just call this one box stacking, even though that's not specifically what this is supposed to be about. And technique number 2 would be, we can just make whatever that final shape is. So for instance, let's just make a helix shape, lie it flat on the ground, make it 0 height, and we'll put a bunch of spirals in there and a different radius. You can see that it's going to essentially just do a spiral and shrink down. So that's all I'm going for. And let's say that that's the final pattern that we want to see. if I were to make a null, and I want this to all be linear, so Control D, project, nope, animation, linear. So everything I keyframe is going to be linear. So on this null, I would like it to get an animation aligned to spline tag. At the time of 0, the align to spline will be following the helix at, let's have it be at the outside. So I'll keyframe that, and all the way at the end of our animation, let's have it at the beginning. So what we should have now is a nice simple null just traveling around at a pretty constant speed, okay? So then it's like, okay, well, this is supposed to be dripping paint. Let's say that we make a sweep. Here's a sweep, and the helix is put inside. And what shape is filling it? Well, we'll just make a kind of nice little round circle. 12 segments around, radius of 1. Let's even go 2 just so it's a little bit thicker. So you can see that that's traveling around. And if we were to tell it to do some start growth, I can rewind this out all the way here. So now we've got another thing that we can have following along. So I would like to drive whatever, this will be our master kind of control right here. So I'll say, hey, whatever this position is doing, I want the expresso to set the driver. It's going to drive this parameter. So then right click on that and say expression set driven absolute, because I want the numbers to be identical. So now as I hit play, what you should see is this null traveling perfectly at the tip of that growing on. So right there, that's a pretty good start. And now that that's happening, now that we know what the final animation is supposed to look like, and I can just scrub through, it's going to be drawn at any given moment, we could make that cup, and we'll do that as quickly as possible. So let's see, scoot that up, and one segment, make it editable, select the loop, actually I'll select the edges, select the loop, delete, back to edge, T for scale. So keep it simple. So that is sort of our cup of paint, and that should be suspended from a string. So parametrically speaking, I can make another helix and give it lots of height, 0 rotation, and radius. So then we get the string. If you want to get real fancy, we can make a copy of that string, put that into a helix, set the helix to radial, and let's pull those all down, increase our radius, tilt them all over. I don't know which axis, so I'll just guess. There we go. So yeah, I could tilt those all over, T for scale, until those are all kind of perfectly matching. And now the helix could look like it's suspending from there. So just a way of making it look like the strings are there. So if that is all happening, I can say, okay, now make a null, move the null up to where the string begins. So that would be hanging off the ceiling. Grab everything involved with the cup of paint. We'll just call that paint cup. And here is a direction, which is Y minus. And I want that, I guess this entire rig's a little bit large. So let me shrink it all down, move the whole thing down. Excellent. So now I want this null to aim at wherever our null is. So paint tip, I'll call our original null. This should come after it, so I'll move it below. And right click, and instead of adding a target tag, I will add a character rigging tag, which is a constraint. What do I want to constrain? Well, I want to aim. What do I want to aim? I want to aim the Y minus at the null, at the paint tip, and now that should instantly move over to where the paint is. So that by itself, you'll see the cup of paint is always pretty much right where our final shape is going to be. So if I were to, we can scale this kind of arbitrarily, so I could make that be a little bit closer. Maybe we should scale it at 0. I don't want to go so far that it's hitting the ground. But yeah, so we can get that going. And then if you wanted the last little bit of the rig going potentially, what's a good way? A simple way would be, I will make a new null and just call this, I'll just call it drip reset our PSR, or reset transform as they decided to change the name. Move this all the way down. I'm gonna move it right to the very bottom of the can of paint. Of course, there'd be a small hole in the can. If we're so inclined, I can Do a loop selection, I for inner extrude, and delete, and that would be our hole there. Wait, we've got this drip now, and we've also got the original paint tip. So I want to connect those two. The easiest way to do that actually is with a tracer object. So say, okay, tracer, you are seeing the paint tip, you are seeing the drip, and you are going to connect all the objects. And now I get a line from one to the other. I'll duplicate that same sweep and feed in that tracer. And I probably want that line to be a little bit thinner. Why is that line so... this is driven. Let me drag that up to a start growth. There we go. So now I should get a line. So it's almost like the centripetal force is flinging that paint out. So essentially you can just fake the entire rig and build it as a rig. And now what's cool about this setup is no matter where I move our spline, it's going to be drawing the shape. It's already kind of existing. So instead of making the bucket draw the paint is making the bucket go to where it would need to be for this to count. So this is, you know, if you wanted like very direct artistic control over it, this is a good method to do. Building out a rig for this type of thing can be, you know, can be very powerful, very useful overall. And, you know, you can always push things a little bit further too if you wanted. For instance, it would probably be nice if you wanted to keep it parametric. I would like this paint on the ground to be a little squished down, a little flatter. And if I want to keep it parametric, I can feed this end side into a cloner and tell the cloner to only be linear of 1, and then I can scale it down via the cloner. So I can say, actually, you are squished. So you can see that gets nice and flat. Then I could probably scale the entire thing up a little bit, and that way I haven't destroyed the original end side if I need to change a parameter. I hate making, or I don't make something editable if I don't have to, because maybe we'll change the point count or something. So, you know, we could make that flatter, and I guess in this case, it'd probably be a good idea to have this just be up a little bit further, get that curvature going. And then if you want to take it a step further again, we could make a new volume builder, and I can feed the paint, both the drip from the can and the line on the ground. We could feed both of those into a volume builder, and as long as we crank our resolution high enough, then we should get the natural advantage of the paint. This will actually blob straight into that final shape. Now, of course, you know, you have to keep on increasing it, and you're going to dramatically decrease your frame rate by doing this. But you can see you get that nice blob from one to the other. So now if I play, of course it's going to go slower, but of course, you know, those meshes look combined in a much nicer way now. Potentially you could do other things where there's growth, or maybe they could even be melting into position a little bit more. And, you know, with this rig, we could have it be any kind of text setup, and everything should just work pretty much automatically. So I did want to tackle kind of this very literal rig. I guess I'll, even though it's the same question, let's make jump that to 2. Paint, drip, shape, rig. But I would love to do a more dynamic one. The way the particles were, maybe we're just at too small a scale, so that the small movement was really not working too well. But I would really think that there'd be a better way to do that. I do have a completely different method. If everybody will indulge me, we can open up another brand new scene file and do another completely different process. The thought here is, what do I want to do? We can, actually just for fun, I'm going to use Slicer, because this was, I kind of learned this technique while making Slicer. So if you haven't seen my plugin Slicer, I think it's pretty cool. It makes cuts in an object, but I'll give it a little mini demo of something I really like, an aspect of it that I really like. If I displace this ground into kind of like a landscape, so in this case I would like a text spline, and said text spline, we'll just do our old friend the ampersand. lie it flat on the ground, scale it way up, filling up the overall space pretty well. Actually, I don't want it that big. We want some fall off here. So hopefully you can see that all right. Anyway, now I want to displace the plane. So I will make a plane effector, which I will rename deformer. It is going to deform the points. It will deform the points by pushing them up. Oh, why is it doing that? I'm clicking there and hitting 0. But I must have been slightly missing, so it's deselecting for me. But anyway, if I push up, you see everything gets deformed upward, which is fine. I'll push that up, yeah, arbitrary amount. In the field, drop in the text spline. Instantly, you're going to see a kind of a crazy shape. Even that could be interesting, but let's make this based on... actually, we'll set it to mask, and the mask will be traveling up and down along Y, and you see we get this ampersand getting extruded out from it. We can increase the distance, and you're going to see we get this nice big fall off. I will actually increase that all the way to all of the edges. And we get this lovely fall off inside of the remapping. If we are so inclined, I could open up this curve and we can do things like curve that to smoothly move in. And this is now the profile coming out from the shape. So we could arc it down sharply or pull it in really smoothly. So lots of different options there. So now that I've got this shape pushing out and down, I can bring in the slicer plugin. And I guess maybe I don't want the shape to go all the way out. Let me decrease that layer radius. Yeah, I just want that maybe a little bit more flat. Okay, so that seems to be working okay. So we get this this nice falling off shape. So now I can go into my plugin slicer, and it needs to be fed an object. So in this case, I can say, I'll remote into it. I always like remoting in. So the source geometry will be an object. The object will be this plane, and we can hide. Actually, I think there's a button for it. Click that, and I can hide the original object. And you can now see that I'm getting a series of slices through that geometry. So we actually see it cut over and over again, traveling up through it. So with that being done, I will auto scale to match the overall height, and then probably shrink it just a little bit so we're not quite on the base. And now we get cut after cut traveling up through. Let's hide the original. Yeah, get a whole bunch of different cuts. Inside of the slicer plugin, we actually have some additional options where I could do something like I want to smooth them. So we can add some smoothing layers in. You can see that all those get rounded out a little bit. And then we've got our, that's the spread. But here, is that the space? Yeah, okay. I can go into the spread and grab my spacing and start shrinking that down. And you'll see that they actually all get flattened out. So this is a really cool way of getting all these concentric lines. And if we were just playing with Slicer, obviously there's like way more settings that we can play around with there. Things like this offset. So I could, oh, no, not that offset, but rate. We can add some rate in here. If I hit play, then all those lines are traveling like through the object, and we can get kind of this nice wobbling line repeating through. You can see that better if I put the spacing back in, where those would be traveling up through the model and looping back down again. But anyway, we don't want an animation. I want it to be flat. So anyway, we've got all these rings. Now, all of that was a really roundabout way of just being like, let's get a couple of slices, maybe even just 3. I could shrink where those are lying. I can even move up and down the null to figure out exactly where they're placed. But anyway, you can see I've got a couple different cuts there. So now that that is happening, I would like a couple of these lines to, actually I want to even them out a little bit. So I'm going to go back into the curvature. And this, you know, while I like this curve, I'm going to just turn that off so they become linear. And I'm doing that because I want to see these lines have a little bit more even spacing between them. So you can see that the space between there and there and there and there is way more even. Okay, cool. So now we've got some different slices just for fun. So then I would like to make a plane, and I'm going to move the plane up to wherever the slicer is kind of living right now. And it's going to have to be pretty dang subdivided. So let's jump it up to like 100. And is that enough? I feel like that's probably enough. And I wonder if we could do this. I haven't ever specifically tried to do this, but if we make a selection tag. What I want to do is make an outline. Here's what I'll show you what I want to do. I want to select every polygon along these lines, right? Because what I want is a vertex map, but you can't put a vertex map on a spline, so we need to do it via geometry. So I want to select all those, but I don't want to manually select them all. So my thought is, what if we make a store selection tag, but we turn on fields, and in the selection tag, I'm going to drag in my spline as a spline object, and I'm going to say I want it to be based on a radius around the object, and that says 10. If I double click there, look at that. I was able to automatically get my selection without having to do anything fancy. And it can be relatively small, something like this. I think that's really all we need to do. So then I'm going to invert, delete, and I'm left with this bit of geometry. So very fast, very clean there. And it's nice and low poly, so our vertex map should run pretty quickly. Okay, so we've got more to do still. So my thought is, let's make a vertex map on this thing. Point mode. And set vertex weights to whatever. And use fields for sure. Don't worry about a freeze quite yet. We need a starting point from this. Now we do have that selection tag. Maybe we could have kept it, but I'm always inclined to just make a spherical field. You see that that's illuminating. I want it to have no fall off, so it'll be full power all the time. And as I move it, you'll see that those little parts will be illuminated in yellow. And I'd like it to begin maybe somewhere right around here. So let's say that I keyframe it. And again, linear keyframes. Keyframe it, and we're going to get a decent number of frames on this. Over the course of 300 frames, I will move it into the center right there. So with any luck, we should pass through that line, that one, that line, that line, that line. We'll be missing that one, but whatever, that's fine. Okay, now let's give it a save. So this will be paint dripping. It's a completely different rig, so I'm going to say 3A. Underscore slicer, because we are requiring slicer. And it's still a paint drip rig. It'll be paint drip rig 2. Okay. So in the vertex map, I would like to do a freeze. The freeze will be above, and I think the correct formula here is freeze set to add, and it's going to be growing. And what is the current distance between our points? I already have 2 points selected, and it's 3.6. So we might add some variation. So I honestly, I'll about double the amount at 6. So anyway, if I hit play with any luck, we should see that strike, and you see how it starts growing. So pretty much what we're aiming for, it starts growing from that point. Now, if I want to slow it down, actually we're going to definitely want to slow it down. We can drop the effect strength down to 10%. So now it should be spreading at 1/10 the speed, and you get a little bit more of a transition as those go, which is pretty much exactly what we're looking for. Excellent. So now we want to get a drip. We want a dripping effect. And essentially the final shape that we want is going to be all these splines. That's going to be the final shape. So the thought now is, let's grab that original slicer, which isn't actively doing anything in the scene right now. And I would like to deform it. So we'll need another plane deform. I'll just duplicate the existing one, but the first thing I'll do is just make sure that it's got nothing in the field, so it's not doing anything. And I believe I can just drop it in as a child of the slicer. The directions get all super scrambled up, so we should be careful. And I'm going to say that it should be modifying it in an absolute way. And yeah, now I can push the entire thing up or down. So if I say, yeah, you're going to fall minus 50, down like that, it's like, okay, now everything's pushed down 50. But if I go into the fields and say, yeah, but you should only push down where this vertex map is nearby. So let's hit play and let it strike that first spot, and there we go. So pretty much exactly what I want, because as this vertex map is nearby, it is translating this fall off into essentially this dripping spline. Now, we want the spline to be subdivided somehow. We can just kind of brute force it right now by enabling the subdivision type inside of Slicer. We built this in, so I can change this to be like subdivided mode. And we can say every 5 units. We already know that that's about 3. So I don't know, let's say maximum length 3. You see a couple extra subdivisions in there, but you'll see it's kind of a little bit, chunky right there. Presumably because the plane deformer is seeing this vertex map. It's saying it's looking at the nearest one, but I'm going to say, actually, I would like you to look at the average of the nearby ones. And we'll make the radius pretty small. And you'll see as I increase the radius, that's going to get smoother and smoother and smoother. So hopefully that's enough for that to become relatively smooth. So now let's hit rewind. And for the most part, we'd be doing things like ignoring this original one. And we want our camera angle to be a little bit low. But now if I hit play, then we should get a drip coming down. And, oh, the average, that makes sense. Maybe we can't do the average technique. Yeah, unfortunately, we can't do the average. So how do we smooth that out? I mean, I could smooth it out with my smoothing plugin, but other people don't have that yet. Well, let me just show you the effect as it kind of stands right now, which is, as long as we're looking down here, we can see all these different lines cascading down and, you know, dripping and forming the shape. And what's really cool is like when they get close to wrapping up, which we probably need a couple more frames for, you'll see that these different lines are going to travel along and eventually they will meet each other and just kind of finish off the shape. So I just really like the way that those look as they fall. Now, a couple different things. First of all, we could make that look a lot smoother if all we did was subdivide our original plane more. So if I select everything and hit US and just subdivide them by 1 and rewind all the way, we should have twice the resolution now. So as this plays through, there's more subdivisions, which means this is going to be inherently smoother. And I guess just to show it, because man, I just got to get this plugin out. Let me find a really jagged spot. But even if we were working with like this really bad, like chunky spline, once I launch the utility splines, we have the smoothing spline. So I could take that and feed it through. And the instant I put that in, you see we get this perfectly smooth curve on that. So based on the smooth, I could say like how smooth I want that to be. So even just 1 or 2 iterations of smoothing. And I can even say, actually, I would like you to subdivide that line by 1, which gives it more geometry to look even smoother. And I can just curve that a few times. So now even with that really bad chunkiness, you can see how smooth that this plugin can then go and make that. So these will smoothly go across, making each one drip and do the effect differently. Modifying this vertex map to grow slightly differently. So maybe some are a little bit quicker, some are a little bit slower. Maybe it's starting in different spots. They're all starting approximately at the same spot because I'm just traveling through one, then the next, then the next, then the next. But I think I just really like the way that this ends up looking as a overall technique. And I mean, right now we're dripping down, but those could be traveling up. They could be deforming in all sorts of different crazy ways. Yeah, I think it's pretty neat. But yeah, I'll pull that out of the smooth because nobody has that yet. I don't know. Does anybody have any? I'm trying to think of. I know that when I was doing it, I might, because the point count here, yeah, the point count here is not changing. I wonder if spring, that's deforming. There's no way to blur that. We already saw that the blur doesn't work because it falls away. So yeah, just subdividing the original shape is probably our best bet here. But anyway, I was going to say, does the jiggle deformer work here? I'm just curious because I don't think it would really help much. But if after the plane deformer happens, can we jiggle? And I usually over crank the jiggle so we can super see the effect happening. And yeah, okay, you can see that the jiggle does work. We can actually get it to bounce. So you see we get kind of this double like wave pattern going. But with that indeed working, like you can see that's actually overshooting and shooting below the ground. There's potentially ways we could stop that with like a linear fall off, but adding like a bunch of drag. I'm just wondering if that would be a way of smoothing it out. Not really. You can see it's kind of making the whole thing ooze down a little bit more, which is kind of interesting. You'll see without the jiggle, that's really sharp. But with the jiggle, it's actually like making the entire thing fall a little bit more even. Just kind of interesting. Anyway, any questions on any of that before I move on to a completely different, unrelated question? We got Slicer here. Turn off the preview cuts so we just see the final spline. Angry Cubes, B-Spline. Ninja Cran, thank you. Appreciate that. Let's see. Victor had something. Or let's see. There's Dean's got a follow up here. If you had two versions of the spline with a morph tag that has a field in it, morph tag on a spline. Do morph tags work on a spline? Ninja Cran, I'm not sure when you say in Rocket Slicer, like in Rocket Slicer. Yeah, I mean Slicer is what is doing. My Slicer plugin is what's making all these original cuts. Could you morph between two versions of a spline? It's a fine question. Let's simplify for ourselves. I will make this slicer editable. Select just this outer spline, delete everything else. So, whatever, we got a spline there. And the simplest thing we could do would be just duplicating all of those points and moving them down. So now we've got two different splines. We've got number 1, we got number 2. Can we just morph between them? And I don't know the answer to that. So number 4A. Spline morph. All right. So the simplest possible thing would be, you know what I want to try actually before I even do a full-on morph is, can we do can we use an inheritance as a deformer? So if I say I want this spline to inherit, can I set that to be a deformer? Yes. Is it going to see it? I don't know. I want spline 1 to be deformed into spline 2. And do we have to say as an animation? I think you would usually say animation, and in which case we should have seen that kind of jump, and it didn't. So I'm thinking you probably can't do this. Although I know a workaround that we could force it to work. But it doesn't seem to be viewing the geometry. Oh, so, okay, inheritance doesn't directly work. That wasn't... The original question was more about the morph. So we can add a post morph. And I want to affect the points. And this is the original pose. The modified pose will be number 2. Yes, as an absolute. And you see, it seems that we were able to morph from one to the other. So then, because we're morphing from one to the other, can we now use a morph deformer? Morph deformer. So what a morph deformer does is, that connector line's not encouraging, but we say, hey, what is this looking at? And it's going to be like, hey, it's applying this shape. Why? What is that? Like, we're only viewing this one, and it seems to be duplicating a whole bunch of the points. Isn't that interesting? It's acting as if there's different point counts on both of them. I feel. Maybe these individual splines are... Let's turn those to none. Okay, better. Okay. What was happening is the morph was seeing the original points, but the spline was creating additional points by subdividing after the fact, so it was making extra points. So that's why I turned off the intermediate points, and now we're just down to the baked points, which is still quite a few. Anyway, now we got the morph tag. It seems to be properly morphing, but because this is the morph tag cannot be fed fields, but a morph deformer can. So inside of fields, we should be able to... grab like a spherical field, hopefully. And yeah, you can see I can pass this through. Does it have to be up? Yeah, it's okay. Up here is where it actually is. So as I pass through a point, I could scale this up, and you can see that that will actually morph from one to the other. Now, that's not perfectly traveling along the line. Yeah, it's going to kind of look like it. It's not technically traveling across. And I all but guarantee this is not going to be able to see any kind of growth. When it comes to fields, they just don't see point objects in that way. As spline objects specifically. Which is too bad because they are like a spline object and a polygon object are both point objects from like a code point of view. But yeah, we can grow that. If I wanted that to be a dynamic growth again, I think I would still need to make like a polygon proxy on the top. But it's good to know that the morph works here as well, and we would get better controlled fall off. And I mean, and there's other options as well now that we're in the world of fall offs. It might be a bad feedback loop, but if we feed in the spline, I'm a little worried it's going to feed back in on itself. But you can see that I can, yeah, it seems to work okay. Well, let's even just do a small range. If I do this offset, that's actually taking, oh, no, not quite what I thought it would do. Well, anyway, you see that it's feeding, I'm feeding the spline into itself, and I can actually increase this amount and actually have it travel along, very controllable. And I could pull this inner part in and have it travel around as well. There's options for sure. On the spline, I think spline remapping. If I go to spline remapping, change this to a curve, and I pinch that in real small, can I then do a spline offset speed? Yeah. So then now that's going to be animating around, which is, I don't know, it's something. It's weird. And then we could curve that in and out. Whoop. Yeah, so now we got more of a smaller lump traveling through. I wonder if that would, I always like these animate. I wonder if that would be able to see like a spring. Can we put a delay? Put a spring. Bunch of spring. Yeah, it seems to. Okay, well that does see it. So yeah, there's additional options. We could smooth that out a bit. You see the relative sharpness of that? And we can smooth it out. And even this goes to if I was being kind of, if you were very linear with these things, if I made these like very sharp and very abrupt. So you see how that's like a really hard drop off. But then, and if I turn off the delay, you can see it's a very sharp fall off. But if we turn on the delay, we start adding in more smooth, I think that's going to, oh, that's weird. Look how it's doing that kind of steppy look. Interesting. Very interesting. I think that makes sense. Because a bunch of points are moving very quickly, so their data can't be remapped. So per step, that's how they look stepped along. Yeah, that makes sense. It's not the most intuitive, but that does make sense. Anyway, I'm going off the rails here, just exploring like really, really specific and advanced things here. The more relevant one, I think, for somebody actually using this is more of the spherical fall off. So I'll save this as the file. Boop. Cool. Victor, could you replicate this in cinema? What do we got? Mute. Let me wait for. Oh, what is somebody short? It is somebody short. So Dacia Studio. Let's pull this over. So that's really cool looking. Okay, so we've got Dacia Studio. It's in Houdini, and they're doing cube organic growth. So you get all these really nice flowy, growy shapes going. You see one of them moves away. That's interesting. You see how like that blob is moving independently? I thought that this was just growth, but they seem to be morphing because like right there, watch, this blob is going to completely disconnect and move up. So there's more to it than just something growing. But if something, that element I almost feel like takes away from it. At that point, I don't know exactly what... If it was growing and kind of morphing around, I'm kind of not even sure what's going on then. And let me think. How would we want to do that? I mean, we could just do some simple particle growing off there, but it's very fractal, where like one layer seems to explode into more layers, which explodes into more layers. We don't have X particles installed, which is the obvious go-to for particle systems. It feels a little ancient to go into thinking particles in cinema, although we could create, you know, particles could create particles there. You could already have a structure built. You have a structure pre-built. And like push it through a volume builder, but I don't think that's a good idea. One of the points here is that there's a lot of different approaches, and a lot of the approaches are mutually exclusive, and each one's going to have their own areas that you can explore, and we might hit a dead end on a particular one, and a different one would work, but that's going to be a lot of time spent potentially traveling down dead ends. And it more goes to, I want to think of exactly what I'm trying to execute on, because there are a lot of things in this general category that could be interesting. I wonder if things don't disappear. Okay, I do have something I'd kind of like to try. I don't know how well this will work. And so I've always actually had a lot of trouble doing it. So this is probably a bad idea, but let's see what happens. So here's the thought. I will make a couple of clones of a sphere onto an object. And by the way, this is not like the way of doing that technique. We're just going to explore some growth effects. So I'm going to clone one of these onto each polygon center, okay? Let's scoot them out just a bit so they're not quite intersecting. And then I will tell a tracer to be tracing that cloner. And currently it's going to be tracing every point. Actually, we won't be able to see anything because they're not doing anything yet. But I'm going to tell it, don't trace the vertices. So in theory, there should be one line behind each of those. Now I'd like those each to become dynamic. So a bullet rigid body, and the original shape will also be a bullet collider body. So they'll probably like pop out from the surface right now and then fall, but I just want to see if the lines are tracing, and yes, they are. So yeah, those are all just going to fall away. Okay, now, no gravity, please. So, simulation. Nope. Bullets. Bullets. General. No gravity. Okay, so now they should just pop away from the surface. Then I guess they'll keep on drifting. I want these to not want to move very much. So we are going to super drain out their rotation and their position. Okay? I think that makes sense. So you see they're going to slow down very quickly. Now, here's where things potentially could get interesting and potentially be not good, but who knows. I would like to make a sweep, and through that sweep, we want something low poly, so I guess I will make an end side because we can go even lower poly, but we'll leave it at 5. T for scale, shrink them down a bit, and I'm going to turn off the caps because caps take longer to calculate. Now, I want you to observe something I'm doing, and that is these are colliding. Do you see these traced lines are colliding with the sphere? So that's very important here. Also, we're going to be doing some dangerous dynamic stuff, so let's save it right away. 5A. pushing dynamics. Let's say pushing bullet, because cinema now distinguishes pushing bullet growth. So here's where things get crazy. What if I take that sweep and I say you are a collider body? So now the sphere moves, it creates some more sweep behind it. The next frame goes to calculate, and it's like, oh, dang, I'm intersecting the sweep. I better move. And when it moves, it then gets traced. So it's a feedback loop. So that's the idea. So that is a collider. It is going to be a moving mesh. And I have no idea what happens in the beginning. It's probably going to explode, but let's hit play. Oh, okay, not bad. We get a couple of lines shooting out, not so great. But we do get each of these moving out all right. Couple of things to keep in mind. The radius of this actually, how do I put this? In a way, I almost want to make this radius larger, because what we want it to do is just barely be intersecting, just a tiny little bit, just enough to scoot it away. Because if we're really skinny lines, then that is actually connecting all the way to the dead center. And suddenly the sphere is like, oh, I have to move that whole distance away, which is almost like forcing a particular speed. I don't know. Let's prove that theory. So let's go frame forward, and we'll see that, boom, it's punching, and you see how they're moving around very, very, very chaotically. And it's because they're trying to escape that intersection. So let me let this go out a bit. But now if I scale this way up, actually, they're kind of like out of position now. So we'll restart. And it should be, already you can see it's a little bit calmer. So if I increase that some more, the hope is that, well, the more that I increase it, the calmer that they will get. That's the hope. Now, if we go really big, they'll stop because they're not intersecting anymore. So we want it to just barely be touching. We can't have zero speed, though, so let's keep that in mind. Okay, it does look like we want it to be forced to move a little bit. Now, we do get these little explosions going, which aren't great. That is going to happen for a very natural reason, which is probably where if this stops moving or it's just kind of jittering around in one spot, then you suddenly get a spline that's doing all these little zigzags. And you know when you pinch a spline really tight that you're going to get something suddenly shooting off. Now, unfortunately, just to throw it out there, I bet you that my smoothing utility spline, let's put that in, smooth, would go a long way to fixing that problem. Yeah, look, almost no explosions now because I'm smoothing out the explosions. If I pull this back, and it's actually not creating the explosions because of smooth splines coming in. But you see, even if they're there, I could say, hey, start smoothing that out, and almost all the explosions go away. And the spline doesn't look very different. But we can't use that yet, so delete. Anyway, I'm just trying to find more use cases for that when I go to record those videos. So anyway, the point being is I would love for these like explodey bits to not be there. Now, we could tell the tracer to be short. So we can say limit this from the start and only be like 5 frames long. So we'll still get the explosions, but they won't last long. Oop, from end, of course. So now you can see that we just get this tiny little bit of tail. And it, hopefully, because there's not that much geometry existing, that it's not going to take more, it's not going to slow down because we're not increasing the amount of geometry in every single frame. So each of these is getting pushed forward. Yes, things explode, and that explosion could clip a different shape, but it's not honestly that big of a worry. And then honestly, how far can we go? Because I might be able to say just like one. No, okay. If I say 1 frame, there's not enough memory of what used to be there. But I bet you even just 2 is going to be pretty good. So yeah, if we even just do 2 frames, it's almost as good as having the entire line be there. So anyway, the point here is we kind of got this self-perpetuating motion going on, which is kind of cool. Now, one advantage, if we do leave the entire line there the entire time, is that they can't pass back over where they used to be. So let's keep that in mind. I want to see if we can affect this in other ways. For instance, can we turned off gravity, but let's make a field force, which should just be applying to everything. And I just want to tell everything to push up. So, there's just a global force pushing up, and we'll say by 40. So let's see if they tend to travel upward. I guess say it doesn't feel like they're tending to travel upward. Let me turn that off and see if they, yeah, as soon as I turn it off, they do all travel upward. But while they're colliding, there might not be too much influence over the direction of it because the collision is the force. Like maybe in general, they'll tend to go up. And I bet you if we made this like really, really strong, that they're going to be tending to get forced upward. The explosions are still happening a bunch. So maybe it does work. We just have to give a you know, a certain amount of strength to try and tend to have it go in a particular direction. And then I do want to tell the path, actually let's have it grow forever, because if we let it grow forever, then it almost like forms a tree, and one of these spheres can't pass through where one of the other ones used to be, because as soon as it collides with it, it's going to push it out of the way. I want to see if we can fix this traced line a little bit. I can't decrease the sample step, but maybe we could change this to a B-spline. I'll give it a uniform subdivision of 1. I mean, yeah, there's extra subdivisions, but it's not stopping the exploding. And it's still like creating a point every time. I wonder. Okay, so like I said, I was intentionally kind of going down a rabbit hole. This is kind of a white whale where I've always tried to do this type of effect, and I always run into particular limitations. Here's a thought, though. What if we don't force those along via it colliding, but we force it along via a field force? So what if I say, hey, okay, I would like you to be viewing this tracer line, and oops, inside of here, I would like you to be viewing the tracer. We're going to need some decent line density. So it's going to be hard to visualize this. I'm going to try and make it relatively thin. We got to keep in mind we're only seeing certain ones then. So these are seeing all of them. The tracer by default, it is giving us a direction. Okay, let's make it more complicated in order to visualize it in a cleaner, simpler way. I would like this to be masked, and it's going to now be masked by being limited via a radius, and the radius will be larger. So anyway, okay, so now what's happening is we're only seeing it if it's close to the line. Otherwise, it's going off into infinity. And now you'll see that near any given line, you see like near this line, like look at this sphere here. You'll see that there's lines aiming in the direction that the spline was traveling. And in this one, there's lines aiming in the direction that was traveling. So this spline is naturally creating a radius, which is now giving a direction saying, okay, push in general that way. So let's just hit play and see what starts out. Very jittery, not surprising, because that tracer, if it stops and then the force goes, and then honestly maybe it's pushing it in the opposite direction. I'm going to invert the direction to start out with. No, not so great. I'm also going to tell this to be an absolute velocity, which probably needs to be slower. Okay. Did I invert the wrong direction? I might want to invert this direction. Maybe better. Maybe. Okay, so we got two different tracers. Let's keep in mind. I should probably even rename this. So this is the radius, and this is the direction. Okay, so they're all pushing perfectly straight out, which actually seems encouraging. It's almost too clean, but like, you know, encouraging, I guess. Now, well, that's pushing in a outward direction. Do we even need that? I don't know. Let's turn that off entirely. Drag in a different tracer. And this one will be looking at the radius. And we'll give it a decent radius. And you can see that we get these little lines pushing away from it. And now actually pushes away in every direction. You'll see in the very beginning. They have to travel enough away so we can actually see it. Look at those little zigzags. What should be happening is like, it's almost like a capsule shape around here, pushing it away. Now it would be best if I could delay it by 1 frame. I have a silly workaround for that. But they are still being pushed away, and it's being done by a simpler thing. It's just being done by a radius. Now Now, let's try the slightly more advanced. We're already making an advanced rig here, so let's go nuts. That's tracing. I say trace from the end, and right now we're saying 3 frames. So there's going to be a tiny little spline. Let's hide the spheres. You can see there's a tiny little line, and you see it's kind of doing this little almost perfectly circular motion. Not surprising. So if that is a tiny little trail, I would like a matrix object to be generated on the object. What is the object? The object is a tracer. I want to create exactly 1 copy per segment loop from the end. So this matrix object, with any luck, let me make this tracer longer so hopefully you can see it. Okay, no, I got backwards, so let's say that that is like this. So now you can see I've got a matrix object that is all the way at the very tail of this tracer. So then let's make another tracer. I'm going to say, okay, but now you're not tracing the original dynamic object. You are tracing this matrix. So now what's happening is we have a tail, and we'll have it go forever. We have a tail, but the tail doesn't start until after a certain number of frames after the original object was there. So that's what we've now created there. So, okay, force object. I would like you to be not looking at the first tracer, but the second one. So this will be tracer cloner, and this will be tracer matrix. Okay, so now the secondary one should be doing the pushing away. First tracer should be pretty short, I think. And let's look at the spheres. And so those are getting created. The first shape is made, and it's trying to force it away. Let's give it a few more frames. Well, this seems worse in every way. Let me think. I guess we could say I'm trying to push it away radially. It could be both, though. I'm going to grab this direction, and we'll make the direction the tracer matrix and the fall off from it. So that one's turned back on again, which is kind of the old rig we had, except it won't be directly on it. So I'm hoping we get less jitter. I guess it's pushing away directly in the same direction again, which hasn't really improved our situation. It's so tricky because, like, I can turn this one on and say I want that to be additive on top of it. Wow, that really overrides. Is that an attractive force? Oh, that might have been the problem all along. When I was working from, let me turn that off. When I was working from that secondary tracer, I had it inverted, so it was getting attracted. That was why I was traveling in a circle, because it's getting attracted to itself. So now this is the simplified version where it's just the radius, and we've got a little bit of lag behind it, and now it's successfully pushing away. So now we can grab that first one and have this be shorter. And I wonder if the matrix rig is redundant now. It's not really changing anything. It has simplified. Because what I really want is we can introduce a little bit of randomness overall. That could be interesting. Okay, I don't know how dangerous this is. Okay, there's a tracer, and it's pushing away from this main line. That's the simple thing that's going on. It's got to fall off. So currently we're saying, hey, if you are within 37, how big are the spheres? The spheres are, let's make them 15. If you are within, let's say, 30 units of the line, you're getting pushed away. So, okay, that makes perfect sense. But what if we say, let's grab another copy of it. And I'm going to say almost the exact same thing. It's the radius. And then instead of saying, hey, if you're 30 away, let's make it 120. So like really big radius on that one. And this time I'm going to say, remember this one we had to invert the direction? Well, this new larger radius, I'm going to say you are actually attracting it. So you are not, you know, it is inverted. It's pulling it towards it. But I want it to be a weaker power. So I'm going to turn that to 0. Oh, does this even work? I think you can only get one value at a time. Add. Yeah, I always think of these in this additive way, but it's absolute. Dang it! Like I said, I've done this so many times. And I keep on thinking that there's new clever ways of doing it. But this doesn't... How do I explain why this doesn't work? The additive force... This larger one is weaker, and both of them are added together at the same time, meaning ultimately the direction telling it which way to go. Like, yeah, it's weaker, but it's still only one direction. What I really want is them to, what I was hoping to do is wrap them around so they're attracted to their own line, but if they get too close to their own line, then it would push them away. Now we can push them away, but the pushing away is always right there on the tip. So maybe if it lags behind a little bit more, which we do have the rig set up for, maybe that could work. So let's give that a couple of frames. What I want to see is some sort of curvature from these things. I'm going to tell this one to be a different color. All right, so they're just kind of hanging around, and then suddenly the line finally draws in. That should be wanting to push them away. Just kind of static right now. Yeah, they're just kind of stop dead there. I guess that kind of makes sense. There's nothing stopping them in the beginning. They have no direction. There's no secondary spline to attract them. Yeah, we're going to probably have to move on from this because as much as I'd like to continue exploring it, I feel like we're going to be in dead-end land the whole time. Well, at least this entire process and methodology. Because, and this was only supposed to be step one. My plan was that we'd suddenly be able to create additional clones on the tails, and those clones could be then pushed away, and those would be trying to do their own branching techniques. Via kind of a manual creation, but I mean, it's not doing an overall attraction, but maybe we could simplify this a bit. That's the larger matrix. We can still say this one is really pushing away, saying that these things cannot it's not allowed to intersect with its own line. That's like its primary goal. And then if we put a whole bunch of random, maybe something happens, but it's definitely not what I wanted. So there's our random. Let's add an add onto that. It's probably a relatively small scale, which is fine. So, you know, in theory, we should see a little bit. No, this is still an overwhelming force just pushing directly away. So what do we make this stronger? Maybe lag it behind a little bit more. Oh, the direction wasn't turned on in that. Interesting. Okay, let's turn the direction back, or turn direction on. Put that back to 1. Let's go step by step here. So, okay, so here is the thought. Okay, it's making these little curls. Or, okay, so there's a random thing moving them around. We should probably make the scale larger, but it's a random thing. And then we've got this matrix line, which in theory should be pushing it away. And they're adding together. So I'll make the random field weaker. So that this line is like, no, push away, like I'm pushing you away, but the randomness can still happen overall. The idea here is it's not that they can't intersect, but it's going to want to avoid each other's lines. And actually, that's actually looking pretty good. You can see that it's not running over its own line too much. And we can push that effect further by increasing the layer radius. So if we double that again, then they should be wanting to avoid their own lines even stronger. Increase the scale here until we can kind of see a visible pattern. A little bit of consistency there. Give it a bit more speed. Rewind. Okay, so that's a little more consistent. And I'm trying to see how well, I mean, it's really hard to see dimensionally. Like I said, and they are going to be able to pass through their own line, but we want it to be pretty minimally. But, I mean, it's hard to tell because that looked like it passed right through its own line, like a whole bunch. Radius gets stronger as it goes. Let's go to remapping, and I'm going to really crank up that inner offset. So its own thing really pushes away. Start that again. That kind of felt like it was sneaking back in. That felt like, you know, that's passing right through itself right there. I mean, it's kind of a cool squiggly pattern, but this absolute direction, I would think that's the fall off, and we inverted the direction. If this was working, we should be able to invert the direction, and they're going to kind of stay in the same spot. So let's just test that. Okay, well, very blatantly they stay in their own same spot. That's a strength, but that's an absolute velocity. I'm going to crank up the power of that like way more. Okay, so these ratios are doing something. So you can see that there's a little bit of wiggle, and they're really pushed away from their own line. That's not a bad thing, because we still have our rig that we can start giving this a little bit more of a tail. Interesting. Lag. The radius is quite large. I made it really strong, so this large radius is not helping us. Drop that to half the amount. Let's drop it to 15. Better. Very... I guess maybe that makes sense, because one segment is not moving until the previous one does, so we're getting these crazy squiggles. That's all about the length of this tracer cloner, or yeah, the cloner tracer. Wasn't my intent to make kind of that stop motion look, but that's what you're naturally going to get when we start increasing this length given this setup. The more I increase this, I think the more that they'll pause. Yeah, this almost becomes the frame rate of them, because that's not really going to move until 23 frames pass, and then suddenly there's a really strong force pushing it away. So pretty funny. If I drop it to 1, it's going to become very quick. What was the last main thing I did? I changed the radius to be very small. Yeah, it's true. Oh, I guess we can set it to a length. Like a tracer doesn't need to be set to limit. Oh, trace paths, space. I thought that there was a setting that you could tell to be not frame based but length based. But this looks like it is always time based. Maybe I'm thinking of X particles back in the day. I'm trying. This is so close. If we can make this be smooth, we'd be talking. The problem we have right now, this is very strong with almost no fall off. Maybe that's our main problem. I'm going to increase the radius so that it's still within the radius, but then we'll give it some fall off. And that should just inherently smooth it. But okay, now it's super traveling in a straight line. It's still really strong, so maybe that makes sense. But we want, okay, it's really strong. That's not a bad thing. We just need to get the right fall off. So let's give that a full range. See what it does by itself. And then change the curve. So if we say, hey, you barely get any effect, But I kind of want it to be like at the halfway point it gets really strong. Little staccato. It should never be in its own radius. Maybe we could do it with two different ones. So like we make it gently push away. So inside of the object, I would like this to not be 1,000%, but it's going to be it's going to be 100%, which means it's pushing away. It's pushing away gently. You see a nice constant gentle movement. And it's going to have a relatively large radius. Layer, we'll say 60. So relatively large radius, saying like, hey, I'm a spline, I'm chasing behind you, and you should try and push away from me when possible. So a constant smooth movement. And now I feed it in again, and I set it up almost identically. I'm gonna say again, this should be along, but the radius will be 15, and it will be reversed. And the strength is gonna be a lot, 1,000. And that's going to be adding to the overall system. So now it's saying, like, it's not allowed to stop because of the bigger one that's saying, like, constantly saying, like, hey, move away. But now there's a really strong force being like, yeah, but if you get really close to the line, like, I'm going to, like, shove you away. With that really large radius, we might be able to give this a little bit more of a tail. No, but the tail still makes it really laggy. I don't know why adding a tail to it makes it laggy. I really don't. I mean, we are getting these zigzags. That doesn't seem too bad. The overall force speed here, I can potentially slow that down. But see, the speed, this power is now directly related to the length of the tracer chasing behind it. So different amounts are going to make it behave dramatically different. Like we're changing two behaviors at once, and you never want two behaviors to be coupled in because then you're fighting it. Where it's like I was kind of designing this to be working at 55, so at about 55 it's looking pretty good. Yeah, as soon as I move it, you get these instant zigzags the instant I tell it to be like all the way up on the tip, which is kind of proving that this double tracer technique is kind of important for it. It kind of feels like. And I mean, these squiggles are, I mean, they're nice squiggles, don't get me wrong. It's not exactly what I want, but we do want it kind of avoiding the overall thing as well, and it's really hard to tell. Let's activate a sweep for this. So I'll pull that out. Let's see how well these look like they're kind of avoiding each other. Oh, look at this. Look at these 2 points all happening at the same time. So even now, even with the rig that we have right now, I feel like it is only moving every other frame. Because, yeah, you can see these double points bunching up. I mean, well, let's see. Like this cluster seems to pass through each other. I mean, yes, it definitely is a bit, but well, actually, no. It's interesting. Look, you see how this is the first line that went here. You can see it travels straight across, and then we've got this other one. And what this one wanted to do was actually probably this line, or maybe it's this one. This one was coming in, and it suddenly got close to that one. It was like whoa, 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 and it suddenly changed direction. So you see that it did avoid it. And then we do have that overall weaker effect saying, in general, avoid this general area. And I think you are getting a decent amount of that soft avoiding. I mean, some of this could be coincidence, but these feel like they softly avoided each other. So, you know, that's not a bad shape overall. But the speed, needing it to constantly move forward but have something lag behind a set distance. That is our trouble right now. The tracer has to be tracing the overall object, so we can't do any fun stuff with the direct children. That just doesn't work. And I mean, you could increase the overall pushing away force, but the thing that's bothering me right now is this every other frame thing. That it clearly is like moving forward a frame and then pretty much not moving, moving forward a frame, pretty much not moving. I like these smooth curves that we're getting, which is kind of like one of the points of this entire process. Maybe right now we just have the randomness. Right now the randomness is pushing things along. I'll save this and continue just for a few more minutes in a different file. And if it doesn't work, then we'll jump into something new. I am going to attempt to, let's just have this random essentially be the driving force. Like if we just say, hey, all of you, you're just traveling around and the only thing affecting you is this random. Then we're going to get like pure random movement. I mean, it should just be, yeah, it should just be there's random. And you see it's actually very not good, honestly. That's actually very, it's popping way more than I thought it would. Oh, the collider. It's got the collider tag. Okay, so this should just be the random movement. Interesting. Oh, that's just a curve. I was like, why is it a second sphere here? But it's just a curve. Okay, so here's what the random is currently doing for us. It's actually moving everything very slowly. So let's try increasing our speed. And I'm going to randomize sample position, so each one is looking at their own. And it's this is strange to me because we're setting an absolute velocity, which means we should be telling each of these spheres that they have to move at a set speed. So I would think that each of these spheres would look like they were moving identically. I think each one of these would look exactly like they're moving at the same speed, but it doesn't feel like they are. If the absolute velocity is supposed to be 555, it seems pretty dang fast, right? But this random is seemingly not. Yeah, you see how they get stuck? And like, oh, these crazy zigzags and everything. Why would that be happening? Like, this is not a collider anymore. And, I mean, I'm just going to bleed all these out because I don't trust them. Well, we're just getting oddness because if we just have this random motion going, these sweeps, these tracers, these sweeps should have nothing to do with it. And yet, yeah, we get trapped in these little, maybe that's not what I thought it was. Maybe that's just getting trapped in a Perlin noise pit, which can happen. That's probably what's happening now. Does anybody know what I mean when I say Perlin noise pit? The when you're actually seeing the box of noise, you can actually get into like a spot where essentially everything's pushing into one direction. Oh yeah, and we randomize sample position, so this just the visually isn't going to give us anything. Let's see. I guess we kind of saw one there. Well, like right here, I don't know for sure, but it's entirely possible that these are saying push down, these are saying push up, these are saying push in, those are saying push out, and it gets trapped in one spot. And we're saying, well, you have to be a certain speed. So as soon as it overshoots, it's going to be like back and forth, back and forth, back and forth, back and forth. Is that what's happening? Maybe. It's very lackadaisical. And this animated, so it would eventually escape. I guess that might explain what's going on there. I guess that's kind of a problem with doing random noise. In a funny way, I wonder if that kind of implies that what we should do is something that doesn't have that problem, which is something simple like a turbulence. where if we give that some speed, these, you know, see how these are more consistently moving? It's essentially, you know, this is what I want, like them consistently moving. And then we do make a field force, but the field force doesn't have any random in it. And we could try saying change direction. And now we reactivate all those other things. And now we say that we do bring in a tracer spline, and I'm going to say that it should be looking at the radius, and it should have a relatively large radius. You can see the radius clearly right there. And the idea, oh, and right now I think it's attracting. If we say invert, then it should be pushing away. Maybe. But we can't have that. It has to be lagging behind. It has to lag behind. Because if it doesn't lag behind, then it itself exists right where it is, meaning it's a valid spot. Yeah. So if we get a proper tail, this starts to tell, like, all this random movement is mostly just from the turbulence is the idea. So like overall there's a turbulence, and now this entire line is saying, hey, stay away from me. So if it suddenly, these do seem to get quite lackadaisical again. See, it kind of stops and it's like it's kind of waiting for the thing to catch up and push it away. I don't want that. Why aren't they just constantly moving? Well, I mean, we are saying that this is a change direction, so maybe that, let's change it to an add velocity instead. Okay, so it seems like that's working a little bit better. So now, as long as this pattern isn't quite catching up to the sphere, then now there should be a strong force that's saying, like, hey, don't get near me, is what should hopefully be happening. Now, I'm going to increase the power of that quite a bit. And actually, we should be able to like crank it up like quite a bit. So these become like no-go zones. And they're going to start trying to avoid it. Now, they could still technically get trapped in one. But now, yeah, the random turbulence is what's actually doing the pushing away. Keep in mind that we're viewing this only this small area. So very quickly, we kind of lose the pattern. And we're kind of viewing it two-dimensionally. But you can see how those lines travel out, and hopefully they're lagging behind pretty well. The way that these are drifting around kind of randomly, I mean, they do feel like they get boosted every once in a while. And it could just be that we need to find the right balance of the turbulence speed and the radius behind it. I think that makes sense. And even that does go to, we can combine two different things where it's like we can have a weak one and a strong one. So, and I've always liked doing that type of thing where if we make a radius, so this one could be very strong. Like let's make that, I don't know, we'll make it like 1,000. So that one's crazy strong, invert direction. And this other one is going to be really big, but it's going to be pretty weak. So I'm going to lower the strength and make it twice as big. So that's going to be constantly pushing things away. So it's like, in general, things like, I want to avoid that area. But then there's another one that's really powerful. And it's like, if it gets really close to the line, it's suddenly going to be like, whoa, I got to get pushed a different direction here. Is an idea. Okay. So now we've got some random lines drifting around just because of turbulence, and in theory, they should be avoiding their own line. They won't be avoiding their own line immediately. Like it doesn't care about the pink line until it exists. So it could, like, in theory, like make a really sharp turn and cross over itself. But after it exists, the idea here is that it should be avoiding itself pretty well. So let's increase this radius again. We don't have that doubling up effect anymore, which is a positive. And let's see how our tubes are doing as far as avoiding each other. We got a knot here, but a knot is not necessarily wrong. In fact, this is encouraging right here, where it looks like this, I don't know what direction it was going, but it looks like it went and it got too close to this tube and it suddenly was forced to turn sharply. That's encouraging. Even here, it didn't double back on itself. To be honest, it doesn't look like anything's colliding too badly. I could be missing something, but it looks like you even like you get these tight areas here where they avoided each other. That's encouraging. Okay, so then we push it one step further, which is like right now it's pure randomness. They're all moving around, but in theory avoiding each other's tubes and their own tube. So now I'm going to give it an overall force of getting attracted towards the center weakly, but we will make a very large spherical field. And the size should be large, but the power should be almost full strength. It will, within the context of the field, it will be adding to everything. But it's going to be pretty weak. So, let's see. Actually, what's interesting, like, okay, there's very little power on the spherical field, but you can definitely see that everything's being very, very much pulled towards the center. But you see how they suddenly will occasionally, like, get flung away really quickly? I'm assuming that's when they suddenly are intersecting one of the really close pipes that they shouldn't be. This is actually a good thing. So if we start weakening the spherical field, they're going to be very loosely attracted back to the center point. So in general, they like to be around here, but not, not too strongly. So, in theory, 51% of the time, they're going to tend to go back to the center point, which means these tubes should get thicker and thicker and thicker. But they should still be avoiding colliding with any of the other ones. Like I say, it's doing a pretty good job of it. It's a pretty good tangle. I would still really love to be using the smooth utility. But it's doing a pretty good job of dodging around. So yeah, that kind of gives, it's giving us some vague growth where the point is we're getting some sort of growth and they're kind of aware of each other. And that's kind of what we've got here. So if they are kind of aware of each other, is there anything else we can do? The main thought had been there could be secondary ones that spawn. But that would be a very manual process. That was the thought. I don't even know how well that would work, but let's just make a second, because all the dynamics will be seen by everything. So if I say, hey, you should be cloned onto here, and I'll set it to a large step. And let's give it a little offset from the start so it doesn't happen right away. So anyway, and maybe some random offset. But anyway, these will all suddenly have a new sphere pop in. Whoa, 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 whoa. Oh, I guess maybe. That might make sense. What's happening, I think, is new spheres are getting born, and those new spheres are directly on the spline, and they're like, whoa, and they're getting flung away because they were perfectly on there. But what's throwing me off is we have a lot of energy draining from here, but they still seem to be getting flung almost infinitely away. So why are they so powerfully flung away? And why are the original ones still so calm? The way they're spawning, yeah, I think there might be more to it, because you see how there's almost like a constant stream of them spawning from a particular spot. Don't loop. Very strange. I would think that those would be losing energy pretty well. I will tell that one to exclude the field force. Let's just see what happens. Interesting. They're still getting flung away. They are not going too crazy, so their energy seems to drain. Turbulence is still being applied to them. But it still felt like some of those were getting flung out into space for no particular reason. Well, yeah, I don't know that we tackled the question in particular very well. I did want to explore this concept a little bit. Obviously, there's a lot of things we'd have to do, and I don't think it's a particularly great rig, but some of the concepts hopefully were interesting to everybody. It's a bit of a refresher for me. You know, the plan was to, you know, have multiple layers of these starting to go, but the entire rig right now is kind of traveling really quickly. It's very... We would need everything at like 1/10 the speed, and then to start branching out, and then put the entire thing into a volume builder so that they all get merged together. I don't see any reason to do that. We are getting lovely avoiding overall. Like, look at these tubes doing a great job of avoiding each other. But yeah. Anyway, I'll save this one where it is. If anybody wants to check it out and try and push it further. But let's see if there's one more question that we can tackle. Yeah, well, if we were using X particles, then there's a ton of different processes that we might have gone completely differently as far as branching and curl noise and things like that. And then, yeah, it even goes to like add, yeah, you're talking in X particle terms, Victor, about like a explosion, advection, and XP branch. Advection is not something I'm super familiar with, and like, yeah, XP branch would definitely be something for creating some of the branching processes for sure. Anyway, Nifty, well, let me check if anything was on YouTube. Yeah, Ninja Cran. Yeah, it's like they're thinking about where they're going to turn before they move in a separate direction, which is pretty much what was going on. Darkwave just asking about Mo Extrude. Mo Extrude wouldn't be very dynamic. Like, yeah, you could make some cool overall shapes with it, but you're not going to be getting different lines avoiding each other. That kind of that requires essentially this type of simulation that we're doing. But Nifty was asking, have we ever tried something like a firework that explodes in a particular shape? That's an interesting question, but unfortunately it does go back into the world of more advanced particle systems. And how would, even if I was doing that, honestly, if you wanted to be art directing things like that, I think we'd want to go more the MoGraph route instead of a particle simulation route, which I don't even think would necessarily be that hard. Let's build a rig. Let's build a firework rig instead of a firework simulation. And I do like building rigs. So we're going to have this shoot up into the air. Let's go up 1,000 into the air. And we'll have it go up in this kind of spirally way. Like that. It's not too crazy. Spiral up. Let's give ourselves a sense of scale. So here's a person. So let's make that bigger. 2,000 tall. So it's not going to be going up too high, but that'll be the distance of travel, or that's the way it's going to travel. And we want to make a particular shape. So when it comes to fireworks, they tend to just be burning like particles of metal. So what I'm thinking is we make a shape of some sort. Let's make... Yeah, we can totally do this. Oh, look, it's already there. I must have searched for it recently. Let's grab the elephant. I'm going to make an elephant firework. So here's our elephant. And it's going to be part of the rig. I'm going to move the elephant until it's kind of in the center. Make a null. Put the elephant inside of there. And we need a matrix. The matrix will be set to object. Now we could set this pattern up however we like. I'm going to put this onto the body, and we could say, hey, give me 2,000 particles, and they're randomly distributed on there. Or if you want to be more organized, you could say, give me on the polygon center, or you could say on every single vertex. We could subdivide it more evenly. This actually might be a good place to feed into our lovely new remesh. And I could, increase the polygon count here and get rid of the adaptiveness, hopefully. So yeah, this is very evenly subdivided. So in the matrix, I can say, hey, view the body. And now you see I've got a much more even count. So essentially, whatever you want the final shape to be. So in this case, I think that's a pretty good shape. Okay, so now I would like to know exactly how many there are. And I don't know how many there are. I guess all we need is the poly count, really. That should give it to us. I turned off it. No, it does still tell me. So 1,631. Undo, undo, undo. Okay, so now I'm going to make a... I guess we can do however we want. We don't need another matrix. We can make our final shape. So I'll make... Let's just say our burning embers will just be simple spheres. I'll make them extra low poly. And they'll be pretty tiny. So I'll set it to 10. Those actually aren't that tiny, so we'll set it to 2. NA and... Yeah, it's a nice bright color. We've got our final matrix. I shall set this to be a linear... Oh, dang it. What was the number? 1361? 1631. Okay, 1631. I would like linear, a count of 1361. So now we have exactly the same count, and you see them all traveling up as a stack. I can say don't travel up in the stack. We had set it 0. So now there is a cluster of like 1,300 spheres all in one spot. I think I would like the elephant to be a little bit lower. And let's hide the matrix. So I'll move the mesh to the top, then the matrix, then the cloner. It's just a good idea in general to have things stacked up in the proper order. So those are all stacked up in the exact same spot. I would like a lovely inheritance effector, and that will come after the matrix, or after the cloner even. And what do I want this inheritance to do? Well, I would like it to go to the shape of the matrix. And I think we set that to animation. Was I doing this wrong before? Why isn't this doing anything? Or is it, and I'm doing it wrong? Oh, morph motion object. Direct morph motion object. Okay, so now you can see our spheres are magically in the correct final position, right? Although I feel like we're missing a few. Did I type in the wrong number? Was it 1631? Did I do it backwards? Yeah, that looks better. I think I switched the number again even after looking it up. Yeah, Dim was just saying I did it backwards again. Anyway, you see it still worked. We're missing a couple. So anyway, we got our spheres in the final position. That's perfectly fine. I think we can turn on a multi-instance to make it run quicker. And here's the best part. All we have to do is animate the... Well, I guess that's boring. It just moves in a linear way. So we need to add some variation there for sure. That's an inheritance effector. So we can go into the field and... is this going to be... This is probably going to be based on the original object, isn't it? Yeah. Because all those are in the exact same spot, this gets applied all at the exact same time. We have other options that we could do. We could randomly do it. That's actually not a bad idea. If I make a solid, then that's a fully applying full power. And then we put a mask on it, and then the mask, I'm going to say I want to be randomly applying things to it and set that to normal. And currently it's based on a Perlin noise, and all of them are in the same spot, so the same noise is applied to every single one. But if we set that to random instead, then actually it's applying to each of them randomly. And yeah, different seeds will be different there if we want. But for the most part, the important thing here is just our remapping. So we've got our overall strength here, but we can also animate our inner strength. And then that's what's actually going to, between these two sliders, that's going to get us to the initial random and then get it into the final position. Is one way we could do it. If we didn't want to do it that way, I mean, I would like to pass something through, but I feel like when a firework explodes, how does it get into that final shape? I mean, we could just have it... Because I don't like animating two different sliders because they never overlap properly. So I'm more inclined to not do it via that random. I'm more inclined to put a random effector already on it. The random effector will calculate before the inheritance. And now that those are already randomly moved a little bit, let me turn that off. You can see they're already kind of randomly exploded out a bunch. Let's make it a lot smaller. So I'll say like 555. So you see that they're in a small bundle right now. And because of the small bundle, when we turn on the inheritance, now that could see something like a linear or spherical fall off. You'll see it's going to be sensitive, but as I pass through, some will begin getting affected before the others. And that's a better process because I'm not animating two sliders. We can just pass this through. And not only that, if we wanted to, I mean, I guess it is because of the way we randomly did it. Like, this is pure randomness. So there's not even a reason to, like, you know, we could do the same thing by scaling it, but I guess it does look a little bit different. I kind of like that. So more goes to, like, exactly how do we want to do this. So let's figure that out. Yeah, we've already got this set up. Field size. So let's just say at frame 50, this will go from that size, and I don't know how long, so let's say up to 70. Make this as big as we have to, which isn't very big. That's already all in the final position. So let's just see what that looks like. So suddenly we've got nothing, and then boom, a big explosion of that. Now it's actually very quick, so let's crank that way further. What just happened? So make that take longer. I mean, fireworks are pretty quick, but let's give it a little more time. I mean, it does get tricky because if I keep on making this longer, I guess what we want to do is ease them out. Is there a way of easing something out? We can ease in and ease out. But can we just ease out? I mean, we could if we pass through it. So, not my super preference, but if we do pass through here, yeah, I think that's going to be the better way. What we can do is go into the spherical field. Let's keyframe it, just be linear, so that can, it's still pretty random, so I'm kind of fine with it. Okay, arbitrary keyframes, pass it through until it's at full power. Keyframe. So right now it's, well, it's mostly linear. I don't think these are literally linear, but I'll set it to linear. So now literally those are moving at a constant rate until they just stop dead. But because they are passing through the linear, they are passing through the spherical field, we can go into the remapping and change the curve. And now keep in mind the curve is only on the transitional spot. But I can say I want you to begin very quickly and you're going to ease out very slowly. So every individual piece here should now pop very quickly. Yeah, that already feels better, where they're accelerating in really fast and they ease out in the end. That feels pretty good. I'm thinking we should make that longer, and we should make that easing out like even more extreme. So they're going to super shoot in and super fade out. And it's going to take significantly longer now. So we get bang, and then they finally get into that position. Okay, so that's the first part. Let's save it. So let's see what we get. We get, and then, I mean, they all kind of go into that position, and then presumably they start to fall away, so that starts getting a little bit more challenging. But let's see. Let's see what we get. And then they'd fade away. Now you can manually keyframe them and them going down, and that's kind of what I'm inclined to do. But then I almost feel like we want the scale to be getting a little bit larger the whole time. But even that's not Right, there's going to be a lot of keyframes going on here. So let's start stepping through. So explode. And we'll make another null, put this inside, and call this one travel. So at the beginning, Control D. We'll go into the F curves because it'll be necessary. So I'll leave the keyframes as they are now. I would like the travel to align to spline. Said spline will be this helix, not tangential. At the beginning, position of 0. At, I don't know, 60 frames, it'll be at position 100. So now we just get this. So immediately we can go into our timeline, spacebar. Oh, okay, fine. F curve, and select this. And here's our curve. Again, I think we want to accelerate in pretty quickly and then have it slow down at the end. I guess it's going to explode, and maybe we want to do this immediately. Maybe I'm going to manually put another keyframe, and I'm going to let it start fading back down again. It's not going to go too far. It's going to take a while to get there, but we get that nice kind of arc up at the top. So, yeah, that could work all right. Hide our timeline. So, let's just see what we got so far. So it's going to travel up, and then, okay, so that's traveling down way too quick. And when do we start exploding? Oh, almost spot on. But then maybe we just don't want to go anywhere near as far down, or maybe the elephant's having shrunk down there. But yeah, I really want to be hanging out up at the peak. So, oh, that's a sensitive pixel right there. Select all, S, get the full framing, and now I can really pull that arc out so we get this nice round curve. Oh, what the heck just happened? Oh, that makes sense. The position spline can go beyond 100%, which means it loops around again. So this curve must go above 100 now. We don't want to go above 100. That's already at 100. So essentially that line, we cannot go above it. So I gotta scoot that whole thing down just a bit. Okay, better. And even this is starting to travel down further than we need to. So let's go, only to 85. And I'll make it later. I'm not sure how that's going to affect the curvature, but it should be okay. Okay, that's fine. And now as the elephant explodes, I think it's doing a fine job right at the time where it is beginning. I think... is that safe? Maybe. What I want to do, I guess we could, you guys know I don't like keyframing position, or I don't like keyframing scale. But I can't really think of a better way to do it. I mean, we could put it into a cloner and all that. I'm not going to bother. Let's just keyframe some scale. I'll set this to object mode and keyframe the scale. And at the beginning, the elephant's kind of that set size. And I want it to, all the way through this entire process, it's going to have continued to get larger. Slowly. It's a little bit larger. So there's a little bit of continuous motion. And I'll just keyframe that. So let's just check that out. So it's going to go... and then we get our shape, and it's going to fade down. So that's going to form the shape, and I think it's like right around here that we get peak elephant. So now we've got this cloner. We could keyframe the scale there. So like at this time, that's peak elephant, and then by the time we get here, they've all have shrunk to 0. We could manually keyframe that. We could also add some randomness in there. I'm just going to manually keyframe it. I don't think it's that important of a detail. And they're full scale at the beginning. I think that's fine, but those will... oh, that's interesting. They're not scaling down. Okay, well, I guess we'll do it with a cloner. I'll make a plane. And it will not move, but it will scale uniformly, absolutely, to -1. And I should just be able to keyframe this strength. So I'll put it down to 0. Go to, I guess right here is the peak. So it's at 0%, and then right here as we get to what is supposed to be the end, we'll shrink them all down. Nice. And now, of course, I think we need a little randomness on everything. So add on a random, and that'll come last. And that one, I mean, honestly, it should be fading through the entire process. And even that, I think, is a pretty good distance. But I kind of don't want to overdo it. So I'm not going to start until around there. And then as we get down to this fading out point, give it a bunch of randomness. Let's just see how that looks. Yeah, that's looking pretty good. Hide the helix, hide the spherical fall off. So yeah, building a rig to do this type of thing, I think, is always fun. We could add, like, there's so many different things of variation we could do here, having different parts of it fall at different speeds. The like all, you know, you want it to hit that kind of moment where it's like, oh look, there's the elephant, and then like have it fade away from there. So the more you let these things overlap, I feel like the slightly more realistic it is. Like this random, which is keyframed on, like it doesn't start until here, but if we started it earlier than that, then the elephant's going to start getting randomized a little bit more. You see that as I pull this back, there's a little bit more randomness there. So you got to kind of pick and choose your moment. And now that's all happening. It would probably be nice to do like a little tracer on there. We'd have to be keyframing that probably as well. But trace from end, 11 frames. Don't trace vertices. Oh, okay, yeah, that did do it. So you get those nice little lines all traveling. And even as it starts falling, I guess... Oh, it's moving with it. Pull this out from the travel. Oh, we even get the line. Yeah, we'd have to keyframe it up into position, but let's just see. They should go up, and we should even get that nice little arc as they start traveling downward. But we'd have to keyframe them to disappear before the movement stops, which is totally doable, I believe. So, like, yeah, by here, we should be at amount 0. I'm not even sure we do 0. Well, we'll do 1. But then here, I think we can be all the way up at 11. And then it shouldn't even start until about 60. So let's just see what that looks like. We'll get a little tail that we could like turn on and disable. Seems to need to be a little bit earlier. We get that little, maybe it doesn't like 1, or maybe they already scaled down by the time I'm making them disappear. But as I said, I can say that the tracer is hidden. So let's record the visibility there. Next frame, it's, I guess it's, well, we'll just say, actually I don't like doing it that way. Let's say on, and the previous frame I'll say off. I always like default. I never record anything with on. So again, that was on, 1 frame later, or I'm sorry, it's default, and then it's off. Yeah, so those do a better job of disappearing. We can probably push that a little bit further if we want to. But I mean, it's gonna be an elephant no matter where we're at. That's cool. Elephants. I feel like there's some definitive forward movement. That might because we gave it that twirl on the way up. Probably let them fade as they go further down. We could add more randomness. Right now, if the random is being applied uniformly across it, but the random could be getting applied randomly. So And I do like those types of techniques where we could be passing a field through it so that the randoms, the different elements would start falling down at slightly different speeds, which could be cool. The whole rig is relatively straightforward in a way that we can, we could make the values significantly different. Like we can make it like really fall apart as it goes. We can make the randomness be a lot more random vertically. Yeah, so there's a little bit more verticalness to the shuffling apart of it. We could make that random happen earlier, as we were talking about. So yeah, it starts kind of spreading out. You still get the like an impression of an elephant, but doesn't push it too far. Making all those illuminate obviously would be really good. Making a tracer or some sort of tail on the rocket going up, modeling the rocket and having the rocket disappear in a particular thing. Having a flash of light at the exact moment where it does the big pop. Each of these could be their own illumination source. The count that we have here is a trivial thing to change. A lot of different ways of rigging this up and adding more advanced things. But yeah, it does go to, like, obviously particles and simulations, and even like dynamic simulations are something I reach for very often. But it does go to, if you need something specific, like we can just build it. You can be like, all right, well, let's manually say, here's the shape, here's what this is supposed to be. I'm trying to imagine properly wrangling particles. It's actually, I'm going to keep rotating, like having a little dimensionality to it, like really fills it out. When it's kind of flat and two-dimensional, it doesn't look too good, or I mean, it looks good, but like you get some dimensionality to it. It's like, oh, look at that. Like, it's like it's an elephant. Parallax on it's cool. But yeah, swapping out this model would be trivial. We just have to make sure we change the point count on the cloner. That could probably be automated through Espresso if you wanted to. Getting some overall movement on everything. The entire thing could still be moving up or down. Yeah, I don't know. Any other thoughts? Anybody? Yeah, step field. I know it's gone back a while, Vlad, but yeah, the step effector would have been a good way of getting some randomness into when they're all clustered on top of each other. The step field would be a way of getting variation. I went with a random method instead, but yeah. Okay, well, I think that's going to wrap this one up. We did tackle a whole bunch of different questions. It's always fun tackling a bunch of questions. We did do a couple. I was going to say we didn't click on any links, but we didn't click on too many links today. Okay, everybody, thank you so much for coming and hanging out. Thanks for asking questions. Yeah, nothing else to announce. I'll see everybody next week for episode 11 of Rocket Lasso Live. Let's see, where is that? Okay, thanks. Bye-bye.